Hello, I want to show you how to make a monopole magnet motor. There are already several videos about monopole magnet motor on YouTube, but they are only showing you how to make the monopole magnet motor, but not how to make the monopole magnet itself. So I decided to split my message into two videos. In the first video I am going to talk about the monopole magnets. In the second video I am going to talk about the monopole magnet motor. The ordinary magnets have two poles, the North Pole and the South Pole. The opposite poles are attracting each other. As you can see, the North is attracting the South. The like poles are repelling each other. So that the South is repelling the South and the North is repelling the North. So one half of the magnet is South and the other one is North. But if you want to make a monopole magnet, it's a little bit more complicated. When you break the magnet into halves, then each one will have its own north and south poles. But this principle can be reversed, and it leads to the solution of this problem. If you join two magnets of the same size, they will act as a single big magnet. And what is even more interesting is that in this configuration, each of the magnets is acting as a single pole. One of the magnets is acting as the North Pole and one of them as a South Pole. So you can see that the North and South magnetic particles are moving inside the magnet, and they can even jump from one magnet to another if they are close enough. The problem is that when we separate those two magnets, the magnetic particles interchange will take place again, and then we will again have two magnets with their own north and south poles. But sometimes the solution we are desperately seeking for many years is surprisingly simple. It is necessary to stop the magnetic particles interchange during the separation of the two magnets. This can be simply done by cooling the pair of magnets to the temperature that is low enough to stop the particles from moving inside the magnets. So when the pair of magnets is cooled to low temperature, you can separate them and they will keep their magnetic particles. And now you have the North monopole magnet and the South monopole magnet. Unfortunately, the monopole magnets are not very stable at room temperature, and they become ordinary magnets again when they get too close to each other. On the other hand, they are stable enough to make some experiments with them. I have two neodymium disk magnets of the same size, and I am going to use them to make magnetic monopoles. An ordinary magnet has two poles, and each of them is attracting the other side of the compass needle. Before they are converted to magnetic monopoles, those neodymium magnets do exactly the same. Now I put the magnets together and I am going to freeze them. So now the magnets are frozen and I have to separate them quickly before they warm up. Now the magnets with two poles are turned into monopoles, like this. I have to keep them far away from each other to prevent the magnetic particle interchange. So I am going to demonstrate the monopole magnet effect. Seems that both sides of the magnet are attracting the south of the compass, so this should be the north monopole. And then this must be the south monopole. Both sides of this magnet are attracting the north side of the compass, so this should be the south monopole. Both sides of the south monopole are being attracted to the north side of the ordinary magnet. And respectively Both sides of the north monopole are attracted to the south of the ordinary magnet. Both sides of the north monopole are being repelled by the north. The monopoles are attracting each other, and if you put them together, they are no longer monopoles.